Everyone, welcome to another episode of AI Guild. Good morning, good afternoon, good evening from whichever time zone you guys are tuning in from. So today we have Siddharth Agarwal as our guest. He is currently working as an AI software engineer at Microsoft, and he's also from my undergrad alma mater, VIT. So I'm very glad to have you here, Siddharth. And I wanted to learn a little more about what you do at Microsoft. You seem to be working on AI pipeline, so I wanted to understand more about what you're doing there.
I'm glad to be here, Aishwarya. Thank you for the invitation on this. And yeah, pretty excited to get started.
That's great. So yeah, do you want to maybe elaborate on your role in Microsoft and how does it work?
Yeah, sure. So I'm part of this team called MadeApp in Microsoft. It's a rotational program, 2-year rotational program, wherein during those 2 years we work with 4 different product teams across the organization and help them get started on their journey of AI development. So the role involves understanding the requirement, understanding the data, and then proposing a solution on which they can build their future AI models, and also provide them with a specific AI model for their use case at this point in time. Uh, it's an acceleration program. We help them accelerate on their journey to AI development.
That's amazing. So I was specifically very, excited about your talk today because you wanted to speak about how to scale, right? From speaking about how we build these models in the notebooks and how we test them to how this can actually be integrated into operational systems. So this is a very exciting topic, and I would not take up too much of your time, and you can start with your presentation.
Thank you so much for those kind words, Aishwarya. So what I'm present, I have this deck ready, which is sort of a deck, but I would appreciate more if we have this going on as a discussion,
Sure.
more from everyone. You're working on the other side of it.
Mhm.
How do you think about those challenges? So
Yeah.
what I've come across is certain scenarios and certain propositions, and what I think about those and how I go about those.
Yeah.
But I would really like to feel free to interrupt me during my presentation and ask me questions and stop there and there. It's not a formal presentation; it's more of a discussion
Yeah.
around how do
Yeah.
we go about this.
Absolutely, sounds good. So we can also pause in between and get any questions that we get on the chat.
Yeah, sure.
Great, great.
So let's share the
Um,
screen.
yeah, here you go.
Yeah. So yes, that's the topic today: building AI solutions for 1 billion users, from notebooks to how do we go from notebooks to MLOps? Just the disclaimer before we begin, that the thoughts and ideas are my own, and they do not represent my team or my company. They're just the way I prefer to do things. Of course, I have picked up a few things as I worked on certain projects, certain ideas, certain practices. But those are just that. Those are just ideas. Those are just practices. Do not represent the company as a whole. And secondly, the purpose of this presentation is to drive discussion and learning. So in the process, if there is any infringement, that's not intended. Apologies before that. So yeah, let's get started. Let's assume let's assume that there is a company called Yosemite, which serves 1 billion customers. The main features of this website is that it's an e-retail website which offers instant delivery to its customers. Um, Now, because it offers instant delivery, it's also able to provide great offers regularly to its customers, and that makes it really popular. Uh, it is so popular that it also offers periodic sales over a short period of time, wherein it says those are great steal deals. So all of this drives a lot of consumption for the website and a lot of traffic for this website. And as a result, the website is able to drive more than 1 billion transactions annually. So that's the scale of the website. It drives more than 1 billion transactions on a daily basis, on an annual basis. My bad. So, given characteristics of our website, Yosemite, they have certain requirement. They need to manage their infrastructure so that they are able to optimize their cost, and they are also able to provide their service reliably to the customers. Now, what do I mean by managing its infrastructure to manage to optimize the cost? Um, Websites need to scale up or scale down depending on what is the traffic that that they expect to be hit. So the third feature of the website where we mentioned that periodically offers sale over short period of time. Those are times of peak traffic for the website. So during those times, there's higher than normal amount of traffic, and for that, the website needs to scale up, needs to have the infrastructure in place to be able to cater to that crowd. Uh, Now, what we want to be doing is be able to predict reliably what is the traffic going to be, so that say we know that tomorrow there is a sale on Yosemite. So Yosemite is expecting around over 100 million customers tomorrow, and on a normal day it's about 10 million customers a day. So it needs to scale up by 10 by 10x. If it does not, it will hit the reliability of the website. Customers won't be able to access the website. But at the same time, if they do not scale up reliably, if they do not scale, if they don't know how much to scale up, uh, the downside of it would be over provisioning it. Uh, Therefore, you would be spending a lot on the infrastructure costs. So therefore they have this requirement of a model which can understand the patterns of traffic and predict the traffic every hour. So this is an arbitrary constraint I've set here, that yes, we want to be able to predict traffic every hour. This could be every minute. The granularity of it can change, but for the simplicity of our discussion, I'm setting it to an every hour prediction. And these are the available data that you have.
Mhm.
You have hourly aggregated data of traffic for the past year. Because we are saying that you want to predict the traffic every hour, you have an hourly aggregated data of traffic for the past year. Along with that, you also have infrastructure deployment over the past year, uh, as to at every hour what was the scale of the infrastructure that was deployed. You also have aggregated performance of infrastructure over the past year. So, what was the average duration of response time for Yosemite to its customers, um, aggregated over every hour? So, say Monday 9 a.m., the performance was a 200 millisecond lag versus say a Friday evening 12 uh, midnight, that was up to 500 milliseconds, or 600 milliseconds lag. So that's the data that you have available. And now I want to ask a question to our listeners here: is how would you go about designing a model for this use case?
Mhm. Um, Siddharth, we might not have that many of responses at the go
Yes.
because these are mostly, coming on from LinkedIn and YouTube. So we might not get that comprehensive of a response here.
Okay. Okay. So yeah, I have a few of the most popular ideas here in terms of how do we usually experiment, or what are the most popular methodologies of experimentation today. So you people experiment locally. uh, you experiment on Jupyter notebooks, and finally you have certain models which you would like to train on online VMs through various cloud providers. Could be Azure, could be Amazon, and could be anyone else. However, the challenges of going through these methods is that um, the data is too large to fit any local machine. I mean, for a website like Yosemite, and on an hourly aggregated data, that just the scale of the data is pretty huge. It's in terabytes. So for you to be able to fit it in any local machine is a task. The second challenge is reproducibility is required in results of the model. So if you tell me that, okay, the past 3 hours of the traffic look like this, and this is why the prediction was, so let's say the past 3 hours of the traffic had a REMA of 15 million users, and therefore we predicted within the margin that in the next hour the traffic would be 20 million users. Uh, at any point in time, if that pattern turns up, or if the same day pattern turns up, the model is supposed to return the same results. So given a data X and result Y, at any point in time, that same result should be reproducible. The third challenge is access of data is business sensitive. Providing, I mean, how much traffic does Yosemite drive every hour? That is definitely something which other competition would be really, really excited to get their hands onto.
Mm-hmm.
So you would not want that data to be lying around loosely everywhere. Uh, so that is a business sensitive data, and Yosemite would be very cautious about giving access to that data easily just to anyone. Uh, the business also wants to be able to pinpoint changes in case of failure and rollback. So, say you come up with a great new model on in your test environment, and the moment it goes into production, the first for the first within the first hour, it predicts that there would be less traffic, and therefore recommends downscaling of the infrastructure, whereas the exact opposite happens. Instead of downscaling the infrastructure, the traffic increases and Yosemite goes down. So at this point in time, we would need to be able to understand what was the change in the model, why did the model fail, and we should be able to roll back to a previous version of the model, so that because it was working, the previous version was working, so we need to be able to go back to the previous version. Uh, and the model should be explainable. At every point in time, you should be able to say that these are the features driving these results. You may not know the exact equation,
Mm-hmm.
but what's causing a spike or what's causing a down spike, that should be explainable. Uh, does that make sense so far? You with me so far?
Yeah, I am.
Yeah. So these are the challenges, and this is where the current methods of experimenting locally, or
Mm-hmm.
using notebooks, or using online VMs fall short. So
Makes sense.
this is where we come in, and this is where we pitch our solution as to how do we overcome these challenges. What is the solution to this? Because these problems are relevant across industry, relevant across companies, relevant across different use cases. I mean, you can have different variations of this uh, going across. So
Mm-hmm.
how do we overcome these challenges? The solution is MLOps. So what essentially is MLOps? What do we mean when we say MLOps? MLOps is nothing but best practices, or a set of processes. Just like we say that we follow agile methodology, or we have DevOps environment of rolling out software. You have MLOps processes to ensure that you have uh, those processes to fall back on to get to overcome those challenges. So what are the features? The first thing is it provides experimentation as a continuous process. So you don't need to wait, or there is no end of experimentation and start of inferencing. Experimentation continuously goes on. Uh, Second is it provides continuous versioning. It provides continuous versioning of your data, provides continuous versioning of your models, provides continuous versioning of your steps.
Makes sense.
Uh, Third is continuous validation. So how did my last experiment impact the metrics which I'm targeting for the model?
Mm-hmm.
So in case of the Yosemite problem, the metric which I would want to chase is what was the margin of error. So say Yosemite predicted that there would be our model predicted that there would be 20 million customers.
Mhm.
Yosemite actually comes back and validates, saying that, hey, listen, there were 18 million customers, or there were um, 22 million customers, or whatever that was. So you have continuous validation going on for your model uh, across. And how does your model impact the business metric along with your own metric at every point in time?
Mhm.
So you have those continuous validation going on. Uh, it provides the process provides visibility into every step. So what do I mean by every step? So you need for a use case like this, wherein you want to have a time series model, you would want some form of pre-processing. You would need some form of aggregation for the data. Even when the model has predicted an outcome, you would have some sort of post-processing, uh, add margins to the prediction, and uh, it could be anything. So whatever that pre-processing or post-processing or even the model inferencing step is,
Mhm.
it provides you visibility as to what is happening.
Got it.
Uh,
So we have a question on the audience, Siddharth,
yeah.
that is this based on the CI/CD pipeline being built?
CI/CD pipeline helps optimize this automation workflow, but
Mhm.
this is not. I mean, what we are talking about here is the process of doing it. CI/CD is a great point which has been brought up, because CI/CD is a software engineering term as such, wherein you want to have continuous integration and continuous deployment to whatever new features you're building.
Mhm.
So you use that philosophy and apply that to your model development.
Yeah, makes sense.
Uh, yeah, I see there's one more question.
Somebody's asking if this works on real-time data validation.
Yes, yes. So there are products out there which implement this, which implement MLOps processes, which you can include in your business requirements, and then this enables you to do real-time experimentation, real-time analysis for any models.
Hmm. And I'm actually going to let you answer this one because I think even I get this question a lot because people are confused about what Kubernetes is actually. So I'm going to let you take this one.
Okay.
They're asking that what's the difference between ML ops and Kubernetes?
Ashura, do you want to take a stab at it first?
Okay, so Kubernetes is a technology. MLOps is a process. So Kubernetes is just a container-based system where you're trying to deploy like models or like any kind of softwares which would be containerized in a particular manner. So let's say you want to run it in a particular kind of environment which has packages in a certain versions, and you want that to be carried forward to any other environment that you're deploying, and that's where Kubernetes comes in and helps. MLOps, on the other hand, is a process. Like it's a process or a way of implementing things that helps you scale the machine learning models into an integrated way. When you're trying to like build these models and have them as a part of any other application or a system. So
Right.
if I did miss anything, you can add on to it.
Yeah, I mean, just one thing there. You're bang on. You're bang on point there. Just one thing there is, Kubernetes is the way, or might be a way wherein you might implement an ML ops process specific to your use case. But ML ops, yes, ML ops is a process, and Kubernetes is the tech which many solutions might use in the background to achieve all of that.
Yeah. Okay, great. So yeah, those were the questions that we had, and somebody has pointed out that they think that the video and audio was lost. Does anybody else on the call feel that? Because I could hear you perfectly well through the call. Okay. Okay, so there's one more question. So Costa was asking if, so with respect to data pipelines, should you buy or build off the shelf, like build or buy off the shelves, and what are the pros and cons of each?
Yeah, so definitely that's a question worth asking. That depends on your use case again. So if it's a simple use case where you do not foresee your pipelines to be changed over a lot over the coming periods, so going off the shelf might suit that use case. However, when you're working with a billion users, wherein you need visibility at every step, you would need customization at every step. Building is the way to go for it, because that gives you that control of tweaking it, going about it. So building it, definitely high. The debt trap is it's high cost and process intensive, but what you get out of it is you get that customization, you get that power to evolve it, you get that power to tune it the way you want it.
Yeah.
The way an off-the-shelf solution might work, you might have to tweak your process to adjust to that. You might have to tweak your infra to tweak to work with that. So yes, it's a great solution. It might be a great solution to get started. That yes, it works for my use case. Let's get started. But the moment your solution or your requirement tweaks a little or goes beyond the constraints provided by the off-the-shelf pipeline, you're left hanging.
Yeah,
So
makes sense. So we have one more question and then we can carry forward
yeah,
with our conversation. So Naveen is asking, how is the versioning done for when you're trying to like build models, right? How do you
yeah.
make sure that your different versions are like in a structured manner and they're in one single place? So is it done by GitHub or is there any other methodology?
So model code versioning, yes, definitely. The products in the market would use something like GitHub. So we have Azure DevOps for uh, uh, Azure AI solutions, and there is GitHub integration as well. I'm sorry, let me just turn off my
I
phone.
know. I was
Uh,
also trying to look at my laptop. I was like, where is this coming from?
no, that's my phone. I'll quickly just start the. I forgot to turn it on silent. Yeah. So basically, for code versioning, you'd use there would be some, if you're using an MLOps solution, there definitely is some form of integration with GitHub, DevOps, Bitbucket, and others. In terms of data versioning, which is the second point mentioned.
Mhm.
Uh, One of the easiest solution is checkpointing your data.
Makes
So
sense.
databases come with an easy built-in solution of checkpointing data. You could have your own checkpointing solution for the data.
Mhm.
Uh, so yeah, so that's how you go about versioning models, various parameters of the models, and also the data.
Makes sense. Makes sense. So there's one more. Actually, there are two more questions, and I wanted to like point these out.
Yeah.
So Sachin is asking that if our model predicts that we need to scale up, and our prediction model service to like serve more customers during the peak times, but the actual numbers are less. Do we still proceed with the scaling up or not?
Yes. So this is where MLOps helps you, right? This is where you define those constraints, where how you define your experimentation. So you have various models in your experimentation stage. What are the parameters on which you would define that the model goes from experimentation to uh, a background stage, and even and this question is actually a good entry point into the next point I was bringing for MLOps. It enables A/B experimentation for further data-driven decision making.
Makes sense. Makes sense.
So I mean, yes, there is a model in which you have great confidence in the background, but you would not. I mean, at least at this scale, you would never release that model directly to all those billion users.
Got it.
You
Makes
would you would do some form of A/B experimentation. You would do some form of production data testing before having the confidence that yes, this model can take over and provide reliable predictions going forward. And yes, even after so many safeguards in place, there might be situations where uh, the model does not provide you with accurate uh, predictions, or might provide you with opposite predictions. So even there you might be very cynical and have safeguards even in production there, that always that this should be my margin of error going. You take in certain margin of error going forward. A. And even after beyond those safeguards, if processes fail, then at that point in time, that's the cost of doing business.
Yeah, that makes sense. So yeah, like as you started speaking about A/B testing and experimentation, maybe we can start looking at that.
Yeah. So this was an introduction into MLOps. I would now dive deeper into each of those points as to how experimentation is a continuous process, and how can you include all of. So this is just a sneak peek, or these are just a subset of the features which MLOps provides. There's definitely a wider world beyond this, but I'm limiting the discussion to these.
Sure,
And not everything might be applicable to everyone, so you might pick and choose based on your use cases and based on your requirements.
sure.
So yeah, let's take a look at each of these in a little more detail.
Mm-hmm.
So experimentation as a continuous experimentation, the first point. So why do I need continuous experimentation? I might want to train my model differently. There might be one training method for there might be 4 to 5 training methods for a model, and I might not be able to get to those all on my laptop all at once. So MLOps does the process of MLOps does that you're continuously experimenting. You're changing your training methods. You're changing your data sets. You're changing your parameters and parameters, and you're changing your environments just to see how robust your model is. So all of this experimentation goes on. All of this if you want to include MLOps, or if you want to adopt MLOps, so these and want to go ahead with the continuous experimentation route, this is definitely something you would want to be doing.
Yeah.
Have train train a single model with various methods, with various data sets, with various parameters and hyperparameters in various environments.
Mm-hmm.
What this does is this gives you a more holistic view of what your model can and cannot do. It reduces the chances that your model in production does not give you with exactly the opposite of what was being anticipated. The next one is continuous versioning. Why do I want to be continuously versioning my data, my model, and my steps? And the reason is these are the questions which businesses usually ask. What data did the model work with? What was the quality of the data? What was the characteristic of the data? I mean, today you are developing this model. Tomorrow you leave this job. A new data scientist comes in and has to take over that model. Those are the first thing you would ask. That okay, I'm owning this model, but what do I own when I own this model? So that is why data versioning is very important. That this set of data
So
was
this that's a part of the data lineage, right?
yeah.
Any kind of like transformations that we're doing, or like any kind of updates, or like new data coming in, all that is being tracked.
Yes,
Mm-hmm.
yes, and or new data is being tracked, and what data was the model trained on?
Trained on, yeah.
Which
Makes sense.
which subset of the data did I use to train that model?
Mm-hmm.
The second question is what is once you've come up with a new model, you would always want to answer the question: what is the difference between this model and the last model?
Mm-hmm.
Uh, Say a doomsday situation happens in production, and I want to revert back. How do I revert back to a previous version of the model?
Mm-hmm.
Or hey, listen, that model, the last version of the model that you were using, some different team in the company comes and says, hey, that last version of the model that you were using was applicable to me. Do you think can I use it? So it drives the versioning also drives reusability and extensibility.
Makes sense. So I have a quick question here
Yeah.
with respect to model versioning. So when you mention model versioning, does this versioning also address any kind of like um, any kind of like retraining, model retraining, or is it mostly happening if you figure out that there's a drift in the model and you're actually creating a new kind of model? So does this versioning also take into consideration whenever you're like retraining the model with new data? Maybe you're not changing anything much with respect to the model, like with respect to say the model structure itself, but the parameters are maybe changing because you're training it on more data.
Yeah. So let me come back to the first challenge question which I had asked, that am I able to reproduce the same result?
Mm-hmm.
Given an input X, do I still get the input Y? So if those set of challenges, if those set of questions are answered, then maybe you would not want to version your model. But even then, you would want to have a minor increment in the model version, because it caters to new set of
Oh,
parameters, a new set of data.
okay. So
But
instead of going from like model version 1 to model version 2, we might go from like 1 to 1.1.
yes, exactly,
Got
exactly.
it. Makes sense.
And just like we talked about model versioning, you would want to have step versioning. So you have, like I mentioned, you have a data pre-processing step wherein you're cleaning your data, you're aggregating your data, or you're transforming your data. So all of those are individual steps within your model pipeline, or your data pipeline, and you would want to version that,
Mm-hmm.
because as the model evolves, each of those steps also evolve,
Mm-hmm.
and you want to track as to how did each of those step evolve in your model,
Yeah.
and can I go back to one of those steps, can I evolve one of those steps individually, treat them as a building block
Mm-hmm.
of your data pipeline. uh, so that's why continuous versioning is important. And what is the solution that you use for your continuous versioning? So for model versioning, the code with respect to specific code, you might use popular solutions like GitHub or Bitbucket or DevOps. For step versioning, or for parameter versioning, you might use checkpointing, or things like that. So yeah, how you implement it is you have popular solutions across, but the challenge is to bring them into your process, bring
Mm-hmm.
them into your development life cycle. Let's move on to the third point of continuous validation. Um, what do I mean by continuous validation? Why do I need continuous validation? Business will always ask you, how much more efficient is this model over the old one? what what's the impact of this new model? So say the last model saved me $20 million in costs annually. The new one is able to save $25 million, $30 million. So what and how are you able to say that? Because the last model was able to predict the actual traffic within a margin of error of say 10%, and this one does that within a margin of error of 5%. Therefore, it has brought down our infrastructure cost by X amount, and that's the savings which is being passed on to the organization.
Mm-hmm.
So that is the efficiency of your model. Uh, yeah. So what is the accuracy of the model? What is the rate of the false positives of the model?
Mm-hmm.
So yeah, that's the continuous validation process, and your MLOps process ensures that you get that continuous validation from your model uh,
Yeah.
every day, every time. Uh, the next point is visibility.
Mm-hmm.
So again, in a catastrophic situation, your data or your model failed, and you want to do an RCA. You want to dive deeper and understand as to what happened, what led to my model predicting a down spike when there was actually an up spike. So you want to at that point in time, you want to know what happened at every step in your model development. So how was the data transformed at every step? How does this step contribute towards the model performance?
Mm-hmm.
So if I pre-process the data one way, the
Yeah.
model behaves one way. If I pre-process the model the other way, the model behaves the other way.
Mm-hmm.
So what is the contribution? Does a change or an increase in something over here led to a spike in prediction, or does it lead to a down spike in prediction? How does that happen? So you want that visibility into every step going in.
Mm-hmm.
And yes, visibility. Another advantage of visibility is, can I reuse this step for another model? Hey, I see that you're taking in this time series data and you're aggregating it. You're taking an early aggregated data and aggregating it over every day. I
Yeah.
think I can probably reuse it in my other model pipeline. Can I do that? Yes,
Mm-hmm.
because you've already checkpointed your step. All you need to do is import that step. Uh, can I update this step? I don't think I need a 1 day's worth of aggregation anymore. I need a little more granularity there, or I need less granularity. I think I can, for another model that I'm building, I want to aggregate over a month instead of over a day. So can I update a step? So you get that fine-grained control over each and every step of the way in your model pipeline.
Got it. So one quick question, Siddharth, before jumping on to the next one. So when we speak about software engineering in general, right, we
Yeah,
have certain kinds of standardizations, right, about how the code should be structured, about like doing unit tests, etc., and making sure that the code is optimized. So there are some best practices that comes with it, and we say that the code needs to have such and such things to make sure that it's a high quality code, and these baselines are generally followed through an entire organization, right? So
right.
similarly, have you ever like come across similar best practices for like data pre-processing and like building like feature engineering pipeline?
Um, at this point in time, there is no one solution which fits all. Aishwarya, unfortunately, no.
I was wondering maybe you have a solution for this
I
because
unfortunately no,
I have
because
also been like looking into that if there is a way that we can standardize this process, right? I feel when it comes to doing data pre-processing, every data scientist does in their own way, and
right.
there's not really a standardization for that.
I can share what I like to do,
Mhm,
which has been successful so far.
mhm.
But yes, this is something which I like to do, and I'm sharing it out here. If
Yeah, sure.
uh, you have any comments, I would be happy to listen, and I would be happy to evolve on that.
Mhm,
So what I like to do is have a data pre-processing class for my data,
mhm,
which which has all those steps or the things I want to do as a configurable parameter. So this becomes a module within itself, and then this module based on the configuration which you want to be using and the parameters for those configuration, you are able to adapt to it. So what it does is you within one package, you bring in that flexibility of continuous experimentation of multiple steps,
mhm,
and what it also does is it gives you that extensibility feature that I today I want to do 4 steps of pre-processing. So those are the 4 configurations I would provide it to my package. But tomorrow I need say 10. I can just build on top of it. I can just extend that class and add those other remaining functionalities. Or if I don't want to use all 4, I need to use 2. So just send in those configurations as that. Yes, these are the 2 steps uh, which we want to pre-process. What I have realized is because there is no one solution fits all, the best way to go about it is define that early on within your model development process,
mhm,
and ensure that understand that there is going to be evolution, and leave as much space as you can
mhm.
for doing that. You don't want to be going in and changing one specific line of code at every point in time.
Yeah, yeah, makes sense. Makes sense.
Um, Yeah. So let's come back to our next point of natural evolution of model. What do I mean by natural evolution of model? So you you've reached a model design bottleneck. Given this architecture or given this approach of modeling, it could be statistical model, it could be a neural network based model, it could be anything. So let's say you're doing a neural network based model, and you're using LSTMs for time series predictions, and given LSTMs, the nature of LSTMs, and given the nature of your data, this is the best your model can do. There is you reach the ceiling of performance for this specific uh, architecture, and you want to come up with a new architecture of doing it. So it ensures that you take an informed decision of uh, changing your approach at every point in time. That yes, I am changing my model because my model design has reached a bottleneck. It's not because of anything else.
Yeah.
Second is technological advancements. Like I said, there might so LSTMs are popular today. Tomorrow, transformers can might come in and just like they have changed the computer vision world, they might change the time series world. Uh, there is a technological advancement, and you want to try that experimentation. So uh, your model is evolving. You went from statistical model to an LSTM model to say a new model. So you understand what has happened at each step with it. Uh, your business requirement has changed. So you brought up the point of business drift, of model drift, right? So we started with the core use case of optimizing the scale of infrastructure for our use case. But tomorrow we want to expand on it and increase it to regional based scaling, or go dive even more deeper into micro level scaling of it. So since the requirement has changed, your model has drifted apart from the requirement. So you might want to retrain your model. You might want to change the model itself because the new requirements are not applicable to this modeling design which you'd gone ahead with. So because you have that granularity, you have broken down everything into those small set of processes. You are you have that visibility, or you have that control as to when does your model evolve, and you can track that evolution of your model at every point.
Mhm.
And the final step is A/B experimentation. This any large company will tell you this is the backbone of whatever they do. This enables them to deliver at that large scale. Minuscule feature changes being experimented they almost on a daily basis with different set of control groups and feature groups.
Mhm.
This is the backbone of this is the backbone with which large companies are at the level at which they are in the software industry.
Yeah.
And this is the single most important feature to
Mhm.
be able to scale and reliably take a decision of when your model is ready for production. When is your model ready? Is your model ready for to be deployed? So you have, I mean, we talked about it, but yeah, you have model confidence in training, but what about production scenarios?
Yeah.
Uh, you want to do an incremental rollout. You don't want to be rolling out your model in one go to all your customers. So you start with say 5%, then 10%, 15%, 20%, 30%, 40%, 50%, and at once it reaches 50% threshold, that's a critical mass threshold. And I mean, this number could change for you, but once it reaches 50% threshold, and it's dealing with 50% of the traffic, that it's as good as a production model. In that case, you have that confidence to phase out the first model and make that as your main model. Uh, we've seen the process. We've seen the five main advantages of implementing the MLOps process. But there are other benefits. There are other side benefits which come along. Uh, it eases data governance. If there is a certain set of data which you want constantly to be monitored as to who's accessing, when are they accessing, there is data. It because you have that granularity that this is the step which is getting the data for me, and this is how it has evolved over a period of time. Uh, your data governance becomes effective. That okay, this is the only identity which is able to access data.
Mhm.
So you don't have 100 different data scientists pulling data all on their local machines and working with data. You know where your data went from the source and how was it transformed. Uh, it helps with audits. Having this process helps with audits. So uh, in the doomsday situation where your model does not perform, it performs exactly the opposite, or even for compliance requirements, you want to know that what has happened to your data at every point in time. Having this process leaves a trail of what happened to your data at every point. What are you doing with your data at every point? Uh, Repeatability. I can repeat that same experiment 100 different times and I would still get the same results. So and that's the single most thing which enterprises require. They need repeatability. They need to be able to do same thing day in day out. Reusability. We saw because you're versioning everything, you could branch out of specific versions of things or use a certain specific step across different use cases, different scenarios. Uh, Extensibility and scalability are the last two. Uh, why do you why did I bring up scalability as the last point? Why was scalability? The whole talk started with scalability at heart, and over here, scalability is the last part of benefit of MLOps. Why is that so?
Mm-hmm.
Uh, because of doing all of those steps, because of having all of those processes or safeguards in place, you have that confidence to scale up. I mean, spinning off a model for on 100,000 different machines is not the challenging part
Mm-hmm.
for scaling.
Yeah.
Uh, the difficult part for scaling is how would the model perform when I deploy it to 100,000 different nodes. What is my confidence level? What would I do in case it fails? Uh, that's the challenge of scalability, and that's because all of these things are in place. You have that confidence to go ahead and say that yes, I can scale my model up.
Mm-hmm.
I my model can cater to a billion users because I have those safeguards, because I have done those experimentations.
Mm-hmm.
Yeah, that's I think that's about it. I loved having this discussion. I had questions in between, but if there are any more questions, I'm more than happy to.
Sure. So a few of the things like I wanted to ask you, right? So when we talk about like having an entire framework on which we can implement ML ops, there's of course like company specific technologies, right? Like every business has their own kinds of framework or like platform on which they actually do these things. But is there any recommendation that you have that people can specifically see in the open source space?
Uh, Within the open source space, that's a good question. I haven't explored technologies in the open source space. I'm extensively working with Azure AI and Azure ML,
Right.
which is actually a really great platform right now, uh, providing with all the customizations which we require, and I see its generalizability across as well.
Mm-hmm.
So, and I mean, over here again, if you're using if you're using a solution provider, there are so many solutions in the market that building a solution on your own might just be reinventing the wheel there. So
Yeah, makes
you
sense.
might
Makes sense.
want to get started on your business requirement and optimize your business requirement
Yeah,
rather than reinvent the wheel where we already exist.
makes sense. So yeah, I think those were the only questions that we had so far with respect to your presentation. So one of the things is, would it be possible for you to share the presentation so I can add that to the description of the video later on?
Definitely.
Great, great. So yeah, somebody had a comment that they felt your deck was very crisp and to the point. So
Thank you.
that's amazing. And yeah, expect it. Okay. Okay. So yeah, we did discuss about the open source part. So I think we covered most of the points that we had. So thank you so much, Siddharth, for joining us and walking us through this entire process. So thank you so much, and thank you everyone for putting in your questions. And yes, we will be sharing the recorded session with you on YouTube, and you will find the deck which Siddharth shared in the description of the video. So great, thank you so much, Siddharth.
Thank you for having me over. I really loved having being here and having this discussion with you, Aishwarya.
Yeah, I would absolutely love to like have you again and talk about any of your other projects that you've been working on.
Definitely. Let's see how that goes.
Great. Thank you so much, Siddharth.